Now let us talk about polymorphism. So in the previous classes we have talked about the two pillars of OOPS, that is first of all encapsulation. After that we have already studied about the second pillar, that is inheritance. Now we are going to talk about our third pillar of object oriented programming, that is polymorphism. So the meaning of poly means many. After morphism means form. So the meaning of polymorphism is doing the similar thing again and again. Right? Suppose let us consider that in the previous example we have constructed a constructor. We have built a constructor. Let us consider that this is my class. After that, this is my student class. In this I am calling student constructor without parameter first of all, and I am doing some work here. After that I am calling again a constructor, with parameter. Here I am passing like some kind of string name. In this I am passing the parameters for my students. So you can see that I am doing the name of the function or the constructor is same, and here I am doing some work here. So the name of the functions or the constructor, if the name of the constructor are same, and we are doing some similar work in this inside the constructor, then it is known as polymorphism. So this is an example of polymorphism. You can see that the student and student. So the constructor name is same, but we are creating it multiple times. We are making it multiple times. So the creation of a function or a constructor multiple times, but the whatever the work going on inside is different. That is known as polymorphism. This thing is known as polymorphism. So what is the meaning of polymorphism? A method or a function in which the name of the functions is same, but the only changes the inside working of the function, that is known as a polymorphism. Those phenomena is known as polymorphism. You can see that here in the first constructor the constructor name is student. In the second one, the student name is the constructor name is student. So the name of the functions or the methods is same. The only change is we are doing some different thing inside our function. This thing is known as polymorphism. So in polymorphism we have two kind of polymorphism types, that is compile time polymorphism. In other words we call it as static. So this is these polymorphism occur when the compilation takes place, that is when our computer or compiler read the code. On this time the compile polymorphism takes place. This is the example of compile time polymorphism is method overloading. In previous functions chapter we have already studied about method overloading, right? So what is method overloading? We have studied, right? If the function's name, the function, let us consider that this is my function and I am passing a comma b, and I am creating the same function but I am passing different parameters here, right? The name of the function is same but I am passing different parameters. These sort of phenomena or these sort of thing is known as method overloading or compile time for polymorphism, right? And another example here is runtime polymorphism. This thing is dynamic polymorphism. The compile time polymorphism is static and runtime polymorphism is dynamic. So these will take place in runtime. When the code is running on that time, our dynamic polymorphism takes place. The example of this is method overriding. So we will study about what is method overloading, with overriding, and all those things in detail. So first of all, what is the definition of polymorphism? The definition of polymorphism is the methods or the function's name is same, but the work going inside the function or the method is different. Those phenomena is known as polymorphism. So we can break our word as poly and morphism. Poly means many. It means that the functions or the methods names is same, and morphism means form. So the forms which is inside the functions, that is different. So by combining this we got our word, that is polymorphism. I hope you have understood the meaning of polymorphism. That is the function's name is same but whatever the work going on inside, that is different. That thing is known as polymorphism. Now let us talk about the two types of polymorphism, that is method overloading and method overriding. The meaning of method overloading is we have multiple functions with the same name, that is function 1, function 2, function 3. The name of the function is same, but the only change here is the parameters which we are sending is different. That kind of example is known as method overloading. Now let us take an example to understand that. Suppose I am creating my calculator. Here I am here I am passing first of all addition. So for calculating addition, I am creating a function that is calculate. In this I am passing int a, after that int b, right? So this will calculate the sum of a plus b. So our calculator will, let us consider that whatever the class we are creating, this class will only calculate the sum of two numbers, right? So this class will calculate or print sum of two numbers, right? I am creating another function that is calculate, and this will calculate for float numbers. So I will pass here float a comma float b. After that I am printing whatever the value that I get as my float value, that is a plus b, right? After that I am passing now calculate for double values. So double a and double b. In this I am printing the sum of two doubles, that is a plus b. So you can see that the function name or the method name is same, but the only change here is, here I am passing integer, here I am passing float, and here I am passing double. So this is the example of polymorphism or static type polymorphism. Here the example is method overloading. So this is the example of method overloading. I hope you have understood the concept. Now let us code this thing. Here I am creating my class after calculate or add, because I am adding two numbers, right? I am adding, so I am creating a class, that is class, and I am going to add two numbers, right? So I am going to give the name, that is add. After in this this is a class. In this I am creating a function void calculate. So calculate will calculate the sum of the given parameters, that is int a comma int b, right? Here I am printing system.out.print a plus b, right? After that I am again calling void calculate. In this I am passing two float values, so float a comma float b, and this will calculate me the sum of two given float values, system.out.print a plus b. After that again I am calculating void calculate for double values, so double a, after that double b. In this I am printing the sum of two doubles, that is a plus b. You can see that here in the line 7, line 10 and line 13, the name of the function, that is calculate, is same, but the only change is parameter. Here in the first example I am passing two integers. In the second function I am passing two float values. In the third function I am passing two double values. So you can see that the parameter is the only thing that got changed. So this phenomena is known as method overloading. So in this in the main program I am creating my class, that is class. I am creating my object, that is I am add uh, addition or add a is my object. So I am going to write create my new object, that is a. After that I am calling my void function. Here I am calling my calculate function, calculate. So a dot calculate, here I am passing 1 comma 2. So let me save this thing and run. So you can see that I got the sum of 1 plus 2, that is 3. So if I pass here in the place of passing integers, now I am passing two double values, that is 2.3, after that 2.4. Now let me save this thing and run again. So you can see that I got my output as 3. After that I got my values, that is 4.69999. This is my double value. Right now I am passing my float values, that is a dot calculate. Now I am passing two floats, that is 1.0, 1.9. After that 2.0. Now let me save this thing and run again. So you can see that first of all I got my integer as my output. After that I got my double value for sum of two numbers. After that I got my float value. So this is how method overloading works. So the name of the function is same, but the parameters which we are passing is changing. This phenomena is known as method overloading. Now let us talk about method overriding. So the meaning of method overriding is parent and child class has both same function, but the definition of child class or definition of that particular function changes when it comes to our child class or in parent class. So to understand that, let me take example, that is I am creating a class that is animal. In the animal class I am creating a function that is void walk. So in this I am printing that our animal can walk, so I can print system.out.print walks. That's all. Right, now this is my class, right? This is my class completed. Now I am going to create its child class, that is class dog. So dog is a part of animal, so I am going to inherit the class of my parent class. So I am going to write extends animal class. In this I am writing the same function, that is void walk. So you can see that the function name is same on both sides. In the child class and in the parent class the function is same, but I am going to change the definition now. That is, my definition will change. Here you can see that the definition is system.out.print walks. Now here I am going to give walks on four legs. So you can see that I have changed the statements which is inside my function. These phenomena is known as method overriding. So the function name is changed, is same, but the only change here is I am going to do whatever the things that are there inside my function. You can see that in the parent class we have only printed walks. So the definition is walk. In my walk class, this will print me walk as my output for animal class. So if I create any object of my animal class, that will print walk. So if I create an object of dog, that is my child class, then it will print walks on four legs. So it will print this. So you can see that the output is changing. The output here is walk. After the output here in my child class is walks on four legs. So the definition inside the function is changing. This thing is known as method overriding. Right? So in method overloading, in the previous video, we can see that the parameters are changing. Here, when it comes to method overriding, the definition is changing. So this is the difference between method overloading and method overriding. I hope you have understood the concept of method overloading and method overriding. Now let us code this thing. Here I am going to create my class animal. In this I am going to write my function void walks. In this I am printing system.out.print walks. After that I am going to create its child class, that is class dog extends animals. In this I am going to write the same function, that is walk. In the walk function, what I am changing system.out.print walks on four legs. That's all. Now let me save this. Here I have to give void type function, right? Yeah, that's all. Now let me create the object of dog. So I'm going to create uh, dog shift is equals to new dog. After that I am going to call my walk function. I am going to call my shift dot walk. Right, that's all. Now let me save this and run. You can see that my definition will get changed. You can see that I got my output as walk on four legs. So you can see that our animal class extended the properties or the function from the walk function. Walk, that is in the animal class we have inherited the properties of walk, but here we have changed its definition, that is walk on four legs. This phenomena or this thing is known as method overriding. Now let us talk about packages in Java. So before we dive into the what is packages and all those thing. Let us take an example that we all use Amazon. So Amazon interface like look like this somehow, somewhat look like this, right? So let us consider that this is my cart. So in this cart you can buy things or you can remove the items which are in the cart. So these symbol is known as cart, and you can buy the things in the cart, or you can remove the items which are in the cart, or you can save it later. So these things you can do from this icon or from this cart symbol. So after that, coming here, you can see that all the matters, all the details, specific details will get shown here. After in the add card we will add that particular element. So add card, we will add item, right? This is used to add items. After these reviews is used to see the reviews. We can see the reviews, or we can give the reviews, or we can dislike the reviews, or we can like the reviews, and all those things. So in the review session we can give reviews, we can see reviews, we can like reviews, or we can dislike reviews. Similarly, in the add card button we can add items, we can remove items. Similarly, in the add card symbol you can buy items, remove items, or save it for later. After here you can see the product images, so you can see that each section of my page or web page or whatever you can say, each section of my page has its own unique qualities, has its own unique functioning. So if I click add cart button, then it will take that particular item to my cart. After that, at the cart I can buy items, or I can remove that particular item if I don't want, or I can save it for later. If I want to buy that particular item for the next time or anytime soon, then I can save it later, right? And I can see the items. And in the search bar you can see that there is a search bar, right? Pen consider here. Yeah, yeah. In the search bar I can search items, I can delete text, and all those things. So each property, each section has its own unique quality, and combining all those things is known as a package. So package, what is a package? Package is a collection of objects, classes. Here these are the different objects that came from different classes, right? So collection of packages and collection of classes, and collection of interfaces, these thing is known as a package. So package is a group of similar type of classes, interface, or sub packages. So this is a group of classes, interface, or you can say sub packages. So this thing is known as a package. Now let us see in coding, in VS Code, how we imported packages of Java, that is Java development kit, how we imported whatever the packages we have in Java. Now you can see that this is my boilerplate code, right? Public class Java basic syntax, public static void main, and we have already studied about classes, objects, and what is access modifiers, and all those things. Okay, now let me create we already studied how to take input from my user. Now I am going to create my scanner class. Scanner sc is equals to new scanner. So you can see that I am getting some error. What is the error? Scanning cannot be resolved type Java. So it is showing that I can't able to find the package or the class you have been entering. So this is the class name. Scanner is the class name, and we creating its object as, and the name as sc. Sc is the object name. After new scanner. So in previous examples for creating, suppose let us take the example that we have created the animal class. So to implement animal class, what we used to write, we write animal, that is class name. After that, dog is equals to new animal, right? This is how we used to create a particular object, right? Similarly, we are creating an object of scanner class, and it is showing me that I can't able to find that class. So to import the class or whatever the packages we have in the Java compiler kit or Java development kit, we write import java.util.star. star represents everything. So you can see that now I am getting no error, that is system dot in system dot in. Now let me save this. You can see that I got my output as scanner is my class name. After SC, now it is not showing error because I have imported the classes, objects, whatever present in my Java development kit. So these things will import all the packages, whatever the packages we have in our Java file. So this is how we use our packages to import the inbuilt classes or inbuilt things. So in Java we have two kind of packages. First one is inbuilt packages. So scanner is an inbuilt package. After system.out.print is an inbuilt package. So these all are these all are inbuilt packages in which we have methods, classes, objects, interface and all those things. So these things are known as inbuilt packages of Java. And the second one is user defined packages. Suppose if you want to create your package on your own, then you create those those things is known as a user defined project, user defined packages. So up to now we have covered about what is encapsulation, what is polymorphism and what is inheritance. Now we are going to study about our final pillar, that is the fourth one, that is abstraction or interface, whatever you say, abstraction. So the meaning of abstraction is first of all, abstract means idea. So in scientific language or in science, when it comes to science language, abstract means idea. So if you have idea, then it is known as abstract. It's just the overlay or the structure of the object that is known as abstract. So the meaning of abstract in computer science is hiding unnecessary details and showing the only important part. So this resembles something. This resembles some encapsulation. In encapsulation, we are combining the methods and attributes, and we are hiding some data which is not that much necessary for our user. So in abstraction also we are doing the same thing. We are hiding the unnecessary data, but here we are also showing the important part that are necessary for our user. So these things, so we are hiding something that is unnecessary for my user. After that I am showing something that is necessary for my user. So these things is known as abstraction. So abstraction, you can say that abstraction is the just idea of a particular thing but not its implementation. So abstraction is just the idea of a particular class or particular object. You can say that specifically particular class. So abstraction is the idea of class. So our class should look like this, our class should have all those things. So these things, just the idea, is known as abstraction. So in abstraction we don't implement anything, right? uh, Only the idea, having just the idea, that thing is known as abstraction. So creating or implementing that thing, that is known as object creation. So let us talk about the properties of abstract class. The first one is can't create an instance of abstract class. So it means that we can't create objects. We can't create objects of abstract class. After that, second property is can have abstract and non-abstract methods also. So abstract can have methods which are just abstract keywords. So we'll write abstract keyword. After it, we will define the function. So that function cannot be implemented. If I write abstract, then that is just the idea. That is not the implementation. So I can't implement. Right? I can give just the idea. Right? After it, can have constructors. So this might sound, the third property, like sound little bit crazy. So in the previous constructor video we have studied that when the object is created, then a constructor is invoked. But here we can't create an object. When it comes to abstraction, we can't create objects of abstraction because it's just the idea, right? So here we can also create, this is the one of the property that you have to remember, that we can create the constructor of our abstraction class. Now let us see how we can create an abstract class. So to understand the concept of abstract class, I am creating a abstract class such that by creating the class you will understand how abstract class works and why we use abstract class. Now I am going to create a class, abstract type of class, abstract class, animal. In this void eats, I am going to create a non-abstract type class. In this I am going to print system.out.print animal eats. After that I am going to create an abstract type function, abstract walk, void type, void walk. So by creating the function of abstract class, I can't implement that because it is abstract, right? That is just the idea. So I can't implement, but it will give me the idea that animals should walk. Animals should walk on ground or in the sky or in the water, whatever the things you can imagine, right? So abstract class, in the abstract class we can have non-abstract methods also, and you can have abstract method also. So abstraction is not like 100% just the idea, right? In abstract class you can also have non-abstract type elements and abstract type elements. Now I am going to create my child class of my abstract class, that is class, uh, let us consider dog or cat. Cat extends animal. Here I am going to inherit whatever the properties, that is first of all I am going to inherit the eat function, function which is there in our right animal parent class. After that I am going to call my walk function. Now in the child function I can implement, so I am going to write void walk. Now I can implement here. Here in the abstract class I can't implement because it's just the idea. Now from using the idea, now I am going to implement it in my child class. So I am going to write system.out.print walks on four legs, right? And now I am going to create another class, that is class, let us say hen or chicken. Chicken extends animal. In this I am going to call my abstract type function, that is walk function. In this I am going to print system.out.print walks on two legs. Now let me save this thing and run. You can see that here I have created in the abstract class animal, I have created a non-abstract type function after the abstract type function. So what abstract type function will do, it will just give me the idea that animal should walk. After that in the child classes I am going to implement that idea. So that is why we use abstraction. So abstraction just gave us the idea that a human should look like this. A human should have two eyes. After it, a human should have should have a sharp face. After it, a human should have a body, should have two legs, two hands. After it, one mouth, one nose, two ears, and all those things. So it will just tell the idea of a particular human, and actually creating a particular, let us consider that for humans we have two classes, right? For males, for females. So for females, they should have like they should have face very square, very symmetric structure, and for male, for gents, they should have faces like very sharp type structure. So we have implemented the idea that human should have face. So we are creating a class that extends the property of humans, right? The class name is female and the class name is male. So in the female class I am going to implement the idea that we have face, right? From the face I am going to implement here that females should have symmetric face, right? After it, in the main class, in the male class I am going to define my face function that males should have symmetric, sharp face, sharp jawline, and all those things, right? So this is the concept of abstract class. So what is abstract? Abstract is the idea, not implementation, right? So this is how we use abstract classes in Java. Now I am going to create my object. So remember guys that we can't create, suppose if I want to create animal, a1 is equals to new animal, so this thing will give me error. This thing should show that the type new must implement the inherited. So this can be, animal class can be only extracted or can be obtained. The properties which are there in my animal class can be only obtained by creating the child class. So we can't directly access or create the objects of my abstract class, because it is just the idea, right? So we can't implement the object type materials, sorry, the abstract type materials, the abstract type classes. So for that reason I can't create its object. Now I am going to create the object of class cat Olivia is equals to new cat. Right, I'm going to call my walk function. So Olivia dot walk. Right, after that I'm going to create my chicken uh, c copy copy chicken copy is equals to new chicken. Right, I'm going to call my function, that is copy dot walk. Now let me save and run. So you can, first of all I have to give braces here, it's some braces problem. Yeah, now let me save this thing and delete this and run. So you can see that our Olivia, that is our cat, walks on 4 legs, and our Kapi, that is nothing but our chicken, walks on 2 legs. So this is how we can abstract or implement the idea which is given in our abstract class. So now let us talk about interfaces. So our interface is a blueprint of class. Blueprint of class. So what this means, what is the meaning of blueprint of class? So we already studied that object is a blueprint of class. Right, now interface, I am telling that interface is the blueprint of class. Right, to understand that, let us take an example that I am creating Maruti 800. So for creating Maruti 800, I will create it class, right? I will create its class. From the class, I am going to create its objects. That is Maruti 800 first car, Maruti 800 second car, Maruti 800 third car. Now, I want to know that what a car looks like. So describing the blueprint of car. So this is a car, right? So describing the blueprint of car, that is nothing but interface. So this is just the idea. From that we can implement our Maruti 800 class, and from the class we can create our objects. So a car should have like around 4 tires and seats of greater than 4 people, and should have a driver seat, and it can move, so it should move. So these are the functions of a car. So interface or the abstract that will describe the blueprint of my Maruti 800 car. That is nothing but here I need to describe the blueprint of car, right? First of all, before I create the Maruti 800 class, I need to declare what is the car. So declaring the blueprint of car, that is known as interface. The blueprint of car is known as interface. Interface. So there are some properties from which we can. There are some like interesting properties of in interface which we use in many of the questions of OOPS. Right now, for interfaces, there are two major properties. That is, for using interfaces, we can access multi-level or multiple inheritance. After we can have 100% abstraction. So in abstraction class, we already seen that we can create non-abstract materials after the abstract materials. But here, when it comes to interfaces, the idea is 100% just the overlay or the things theoretically, but we can't implement the thing here. 100% abstraction will take place and multiple inheritance will take place. So in C++ we can separately create multiple inheritance, but we can't directly create multiple inheritance in Java. For that we use interfaces. So if let us consider that this is my base class 1 and this is my base class 2, and from this combining these two are in combining these two, I am creating a derived class, that is T1. This is my inherited class. From inherited class, and from B1 and B2 I am inheriting the properties of B1 B2. These thing is known as multiple inheritance. Now let us see what is the actual meaning of interface and how we can understand the meaning and the working of interface in detail. To understand that, let us code this thing. So to understand the meaning of interface, let me create an interface. First of all, write interface. After it, chessboard, chess chess moves or chess players. So if we have played the chess, then we know that each player, or in chess we have like a queen, a king, a rook, and all those things, and all those players, all those whatever say, like I used to say like players, all those king, queen, rook, all those players has their unique moves. So in the interface, what I told you, that interface is just the blueprint of class. So it will tell me that it should have moves, that's all, right? I can't implement those things and all those things, right? All kind of things. Now I am going to write my class for queen, for queen. So for inherit the properties of our interface, I have to write not implement, but not extend. I need to write implements chess player. In this, I am going to write the moves for queens. So moves here in this. Now I can implement. That is system.out.print. So our queen can move up, down, left, right, diagonally. Right? These are the moves of queen. So it can move up, right, top down, left, right, after diagonally. So it can move anywhere it wants. So here I am implementing the moves of my queen. So this thing is known as implementation of my interface, or definition of my function, right? After that I am going to create another class king. King implements chessboard. So I'm going to write public void moves. In this I'm going to write the king moves, that is up, down, up, down, left, right, diagonally, only one move. So our king can only move right one step, right? That's all, only one move, right? These are the moves of king, right? After that I'm going to write rook moves. So rook implements chessboard, chess player. After its moves, that is public void moves. In this I'm printing system.out.print. Our rook can move up, down, left, right. That's all. Now let me save this thing, and here I need to give public void. That's all. So you can see that this is my interface. In the interface I have declared the idea that chess players has some moves. So I have declared just the idea that our chess players should have some moves. After that, in the class I am declaring the each move of each player, right? For queen I have declared, after it, for king I have declared, after it for rook I have declared. Now let me create an object of my child class. For queen I am creating class, right? Queen q1 is equals to new queen. That's all. Now after that I am calling my function for moves. So q1 dot moves. That's all. Now let me save this thing and run. So you can see that I got my output. The moves of queens are up, down, left, right, diagonally. Now I want you guys to do a homework after listening to this lecture. I want you guys to go into Google and search about abstraction and interfaces, and study about that topic in detail, and try to understand it yourself, because it is very important to understand the concept of interface and abstraction. Now let us talk about static keyword. So these static and super are very small concepts, and at the same time a kind of important, and when it comes to technical language, static is kind of important thing to understand. So static keyword in Java is used to store the same variable or to share the same variable or method of the given class, and it can be applicable for properties like string, color, after the string tip, and all those things, after functions, for functions like void walk, void sleep, void breathe, and all those things, after for block of code. So block of code is nothing but our whole class is a block. After function, declaration, definition, and calling is a block. And for nested class also, so what are nested class? Writing, suppose like this is my C1 class, in this again I am declaring C2 class. So these C2 is a nested or the inside class of my outer class. So this is my outer class and this is my inner class. So combining these two things is known as nested class. Let us see example of my example to understand what is the actual meaning of static. Now I am going to create a class, that is student class, right? Let me write class student. In this I am writing string name, after that string roll number, after that static I am making it as static string school name, right? After that here I am creating a function, that is void set name. Here in this using this function I am going to set the name of my user, that is set name. In this these dot name is equals to name, right? After string type function I am going to return the name of my user, that is get name. After here return string. So let us code this thing. By coding this I will tell you the meaning of static keyword. Now I am going to create my class, that is class student. In this I am going to write a string type function, that is a string name, after that string roll number, after that string school name, right? Now I am making these school name attribute or keyword as a static, so I am making it as static, right? Now I am going to create my set name, void set name. In this I will take parameter as string, right? After this dot name is equals to name. After that string type function string get name. In this I am going to return string, that is our name. That's all. Now I am going to create two objects for my main program. In the main program I am going to create two student objects, that is student s1 is equals to new student, right? After student s2 is equals to new student, right? Here s should be small, yeah, right? I have created two objects of my student, that is s1 and s2. Now I am going to assign the name of my student, that is s1 dot name is equals to Jabir. After that s1 dot roll number is equals to c9. After that s1 dot school name is equals to mits, right? Okay, now I am going to assign the name of my, here I am printing the name, whatever the, here I am passing the name of my that is I am printing, here I am printing get name function. I am calling my get name function after for my s1 student, that is s1 dot get name. After that I am creating s2, for s2 student I am getting s2 dot set name, I am setting name as suppose let us consider that Lokesh. After that I am going to assign the roll number for Lokesh, that is roll number is equals to B9. Right, after that I'm going to I'm not going to assign the name, the school name of my right Lokesh student. After that I'm printing system.out.print. I'm printing his name, that is s2 dot name. After that what I'm doing, I'm printing his school. Here you can see that for my object 2, that is s2, I haven't assigned the name of the school, but you can see the magic here. Now I'm going to call my function, that is s2 dot school name. So I haven't assigned anything, so if I run this code, then it will give me a blank space or blank string. Now let me save this thing and run. So you can see that I got my output as Jabir. Now here let me also save and print the school of Jabir also, that is s1 dot school. Right, now let me save this and let me delete all these things. Right, okay, now save and run. So you can see that Jabir and his school name, that is I have assigned here. You can see that in the 11th line, in that 9th line I have assigned s1 dot school name is equals to MITS. So I have successfully assigned the name of the student, that is s1 dot school name is equals to MITS. After that for s1 object I have assigned, but for s2 I haven't assigned the school name for that particular object. But you can see that for s2 object the name is Lokesh, and for s2 object the school is also MITS. So you can see that for all the variables that I am creating, the value of school will become MITS. So this is the meaning of static keyword. I hope you have understood, right? So static, when I write static, then it will get applicable for whatever the objects you are creating. That value, that static value will be applicable for all those objects of that particular class. So this is how we use static. So if I want to like assign a particular thing that is like used in every object, then I will make it as a static. So by making a particular keyword or function static, I can assign like all objects by that particular attribute or by that particular statements. So this is how, if I want to like assign the things which are there in my keyword for that particular object or for a group of objects, then I will make that particular keyword. You can see that for assigning, or suppose let us consider that I have created 10 objects, that is like Jabir, Hussein, Lokesh and around 10 students, and I don't want to give them separately like Jabir dot school name is equals to MITS, Lokesh dot school name is equals to MITS. I don't want to give it separately. So for that particular reason, I can make it as static. So by just making that keyword static, it will get assigned or applicable, or it will get applied for all the objects of my class. So this is how we use static keyword. After static keyword, there is also a special keyword, that is super. So super keyword is used to refer the immediate parent class of a particular object, and there are some properties, right? To access parents properties, if I want to access all the properties of my parent class, then I will write super keyword like this, super, that's all. So this will access all the parent class properties. After that, to access parent class functions, so if I want to access the methods of my parent class, then I will write super keyword. So this will access all the things. And if I want to access the constructor of a parent class, then I can write super keyword and it will access all the things which are there in my parent class. So if I want to access the immediately access the parent class, then I will use super keyword. To understand the working of super keyword, I am going to create my class, that is animal. Animal, in this I am going to write animal constructor system.out.print animal constructor is called, right? Okay, so after creating animal constructor, I am coming out of my class. Now I am going to create a child class, that is, let us consider that cat extends animals. Here I am creating a function, that is constructor for cat, that is cat. In this, first of all, I am extracting whatever the functions, whatever the attributes which are there in my parent parent class. So to access the parent class, I will just write super parenthesis. That's all. This will like take all the functions, all the properties of my parent class. After that, I'm going to write system.out.print cat constructor is called. That's all. Now let me save this, and in the main program I am going to create my object of my class, that is class Olivia. Olivia is equals to new cat. After that I am creating its like I am calling the constructor for my cat. So I am calling constructor. That's all. Here you can see that in the new cat I have called my constructor. Now let me save this thing and like run. Running this, you can see that we got our output, right. So here I am not, like you can see that in the class constructor I am not writing that animal constructor is called. I am just writing super keyword. So super keyword will call my parent class, and in the parent class constructor I am writing that animal constructor is called. So the whatever the functions we have that got extracted or that got implemented in my child class by writing super keyword. After that I am printing cat constructor is called. So cat constructor is called. So this is how we'll implement or immediately take whatever the elements, attributes, functions present at that particular parent class. So if I want to access immediately, then I will use super keyword. So by writing super keyword, I can access whatever the properties, methods, functions, all those things from my parent class to my child class. So this is how the things work. So up to now we have completed the important concepts of OOPS, like what is class, what is object, polymorphism, encapsulation, inheritance, and abstraction. So we have covered like almost everything which is like very important in this chapter when it comes to object oriented programming, right. We have seen what is shallow copy, deep copy, what are the types of constructor, copy constructor, and very we have gone into like concepts of those things in detail. So we have completed our chapter, that is object oriented programming, and now we will start our next chapter, that is very interesting chapter, and personally it is my favorite chapter, right, that is recursions. So with that being said, I will see you in the next chapter, that is recursions.